What are derivatives? Take a simple function like x squared. Say you wanted to find the slope of the function or the rate of change. How would you do that? See, that would be kind of hard because at each point in this graph it has a different slope. But what you can do is you can find the average slope between 2 points on the graph. The slope, or m, would be the change in y over the change in x. So in this case, 0 minus 4 divided by 0 minus -2. And in this example, the average slope would be -2. But we see that this isn't exactly that accurate. What we can do instead is we see that as we bring these points closer and closer, the slope gets more and more accurate. And if we could get these 2 points infinitely close to one another, we have what is called a tangent line, where essentially this line touches the graph at only one point. The derivative is essentially the slopes of the tangent lines across the entire graph. And so we can say that the derivative is the rate of change of any given function, even ones like this where the rate of change is not constant. Some derivatives are easy, like straight lines. We would say that the derivative is the slope of that line because the function only ever changes by the slope's amount. And essentially, the derivative allows us to find the slope at any given point on this graph. Let's try to get a more concrete definition of what a derivative is using limits. We have some function f of x, and we have a value h, which is meant to be some infinitesimally small change in x. We say that the derivative of f of x is the limit as h approaches 0 of f of x plus h minus f of x all divided by h. The denominator is actually x plus h minus x, but the x's cancel. This might seem confusing, but just look here. All this is the change in y divided by the change in x, our traditional definition of slope. And the limit allows us to have our change in x approach 0. From our visualization before, this means we can find an exact value for the slope of two infinitely close points to one another. No longer do we need to use an approximation. Now, using this definition, let's find the derivative of x squared. F prime of x also denotes the derivative of f of x. We say that is equal to x plus h quantity squared minus x squared, all divided by x plus h minus x. This, like I said before, is just the change in y divided by the change in x. Let's expand out this x plus h squared term. Our expression then turns to x squared plus 2xh plus h squared minus x squared, all divided by h. The x squareds now cancel, and we are left with 2xh plus h squared, all divided by h. And now here is where we do a little bit of algebra manipulation. We artificially get rid of this discontinuity by dividing every term by h. This allows us to then after substitute in h equals 0 to find the value of our limit. And then we see that the value of the derivative of x squared is just 2x. We will learn later quicker techniques to find derivatives, but this is the fundamental definition of what a derivative is. And that's all you need to know to understand the basics of derivatives. If you enjoyed it, feel free to like and subscribe. Thank you for watching.